Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video, we'll go over imaginary numbers and how to simplify them. An imaginary number has its unit as the square root of -1, and we label that as the letter I. So I is equal to the square root of -1. That's called the imaginary unit. And it's like the number 1 when we talk about real numbers. Now, imaginary numbers, when we think about the square root of a negative number, we're trying to find a number times itself that gives us a negative result, and we can't find that in the real numbers, so that's why we need these imaginary numbers. Now, another feature of the imaginary unit I is that I squared then is defined to be -1. So when we're working with imaginary numbers and we run into I squared, we can replace that by -1. Finally, when we work with the square root of -a, where a is some positive number, we can rewrite this as I times the square root of +a. Right? Let's simplify some imaginary numbers, and we're going to start with a review problem first. We're going to simplify the square root of 40. Now, this is not imaginary because 40 is positive, but trying to simplify that radical, we're trying to pull out any paired factors that we can from inside the radical. And there's two ways to do it. First, we can think of 40 as 2 times 2 times 2 times 5. So if you used a factor tree and broke it down to its prime factorization, now we're looking to take these out in pairs. And there is one pair of 2's that can come outside the radical as 2, and then we multiply the leftover single pairs, 2 times 5, or 10. So that's one way we can think of it. Another way we can think of this is by rewriting as 40 of the product of two numbers, one of which we know is a perfect square. And so the perfect product here is 4 times 10, because we know the square root of 4 is 2. And again, that gets us to 2 times the square root of 10. Now, if you look at example 2, the square root of -40, this is exactly the same as problem 1, except we're going to have I introduced. And so this is equal to 2I square root of 10. Sometimes we'd like to write the I after the radical, so we can treat it like a variable and the rest of the numbers are the coefficient, but typically we'll put it up in front of the radical when it's been simplified. Okay, square root of -16. Because there is a negative number inside the square root, I know that I'm going to have I in my result. Then I just have to worry about what is the square root of 16. And the square root of 16 is one that we know because 4 times 4 is 16. This is the same as I times 4, which we can write as 4I. If there's no number left inside the radical, then we can write the letter I at the end of the number. Square root of -54 is the next example, and I know that -54 means that I'm going to have an I in the result, but I also know that 54 is the same as 9 times 6. And I know the square root of 9, that's a perfect square. The square root of 9 is 3, so I can get a 3 out of the radical. I'm going to write an I in front of the radical, and what's going to be left is 6 inside the radical. So the square root of -54 can be rewritten as 3I square root of 6. In the next example, we're going to multiply two radicals, and we need to simplify the I part first before we do any multiplication. So I'm going to do two things at the same time. I'm going to pull the I out of each radical, and at the same time, I'm going to break down both numbers inside into their prime factorization. So square root of -15 is I times the square root of 3 times 5. Square root of -6 is I times the square root of 2 times 3. And now I can multiply these radicals together. I can't multiply -15 times -6. I need to simplify in terms of an imaginary number first, then I can multiply. I times I is I squared. And when I look at the 4 factors in the two radicals, I see 3, 5, 2, and 3. I've got a pair of 3's that can come out as a positive 3. So 3i squared. What's left inside are the 5 and the 2. 5 times 2 is 10. Now, this isn't simplified because anytime you see a power of I larger than 1, we can simplify that further, and I squared can be replaced by negative 1. So this is the same as 3 times negative 1 times the square root of 10, or simply negative 3 square root of 10. Basically, when you see an I squared, if you take away the I squared and change the sign of that term, that's simplified. Let's take a look at example 6. I've got the square root of negative 30 over the square root of negative 6. I'm going to begin by taking out those i's first. So I square root 30 divided by I square root of 6. When we have a square root in the numerator and denominator, we can divide that into a single square root. Also, I divided by I is 1. So we can divide those away, and we're left with the square root of 30 over 6, which is the same as the square root of 5, because 30 divided by 6 is 5. Another example involving division, notice this time the numerator is going to be imaginary, the square root of negative 18, but the denominator is not. So I can start by rewriting this as I times the square root of 18 over the square root of 2. That becomes I times the square root of 18 divided by 2, which becomes I times the square root of 9. And we know the square root of 9 from an earlier problem is 3, so this can be rewritten as 3i. One last example, and we'll see this when we get to the quadratic formula, a formula used to solve quadratic equations. A lot of our solutions will be of this form. A number plus or minus another number inside a square root over another number. And this time the square root has a negative number inside. So that means that I know that I'm going to have I when I simplify this. So 32, I can rewrite that as 16 times 2. And that's a convenient factoring pair because I know the square root of 16 is 4. So that tells me I can take a 4i out of that square root. There's still going to be a 2 left inside. So first step, 12 minus 4i square root of 2 all over 4. Now there's a common factor of 4 that I can divide out of each term. I could also factor the 4 out of the 2 terms in the numerator and then divide. But when you have 2 terms in the numerator, 1 in the denominator that share a common factor, we can simply divide that factor from each term. 12 divided by 4 is 3. 4 divided by 4 is 1. 4 divided by 4 in the denominator is also 1. So we're left with 3 minus 1 times I is just I, square root 2. And the denominator is 1. And when we have a denominator of 1, we do not need to write that. So we have 3 minus I square root of 2. Okay, that's it for imaginary numbers. In the next video, we'll talk about working with another type of number, a complex number.